Well, good afternoon and welcome to today's webinar on feed waste. My name is Caitlin Reeser and I'm hosting this afternoon's webinar. A couple of housekeeping items. If you want to ask any questions today, there is a question box where you can write in your question, address it to me as the organizer, and I will ask Barry throughout the presentation. I will be asking him questions, so keep them coming throughout. Also a note, the webinar is being recorded and you will be sent a link by email tomorrow. So our webinar today, again, is on feed waste. The amount of feed waste from bales fed on the ground versus in a bunk feeder may be more significant than you think, with feed costs contributing to the main cost for a cow-calf operation. Finding ways to cut feed costs can prove significant, and today's webinar will explore the feed waste issue. Our presenter today is Barry Yaremcio, Beef and Forage Specialist at the Alberta Ag Info Centre. So Barry, I will turn things over to you.
Thank you, Caitlin. The information that I'm going to be presenting today is work that we did at the Ag Canada Research Station in Lacombe back in 2007, 2008, 2009, where we conducted the experiments of feeding cows on the snow using a bale processor or feeding cows in bunk feeders as well. So, why did we want to do this trial? Well, the first thing was, at that point in time, there was a lot of discussion in advertising and at farm shows where if you use a bale processor, it's going to improve the quality of feed. You're not going to need to use as much feed, and therefore it's more economical to process rather than feeding the material long in either feeders or silage in bunks. So when we looked into it, there was no data, there was no scientific research done to determine what was the amount of feed wastage when hay or silage was delivered onto snow. Previous work where they just measured hay loss out of feeders, they looked at the gross loss. If they had 20 pounds of hay on the ground, they figured that that was 20% or 20 pounds of material being lost, but they never evaluated, was it the long stems, was it the flowers, was it the leaves, or what portion was being lost, because we know that the leaves and the petals off the flowers are the highest quality portion of the feed that's there, but nobody had ever broken it down into a second phase instead of just using gross losses. And the other side is, does the advertising, or did the advertising at that time really substantiate the claims, or was there something else going on? And we'll discuss that later on. So I'm going to just go through a little bit on the background of what we did. In November, we laid out some geotextile fabric, same stuff that they use in highways, and we wanted that to be on the ground underneath the snow so that the cows didn't have the ability to lick the feed off of the top fabric, and there was no interference with what was actually happening on the ground when the cows started eating there. So in February, when we got a lot of snow, the first week, the 4 inches of crust and ice, we had about 6 or 8 inches of snow when we started feeding the first week of February. Then we got a Chinook. It started to warm up, and we thought we were going to lose the experiment. But actually, before we put out the second layer of our second week's worth of feed, we got another 8 inches of fresh snow. And as you can see by the picture, it was quite substantial, and it really made a big difference on, how the cattle moved and what they did. So prior to feeding, we laid out collection tarps so that we could get the feed. So the processor would lay the feed across the tarps so we could get a representative sample of what was being put out, the number of pounds of feed per linear foot, and then once we got those measurements in there, we'd go ahead and put the feed back into the windrow before the cows were turned out to feed. So they still had that continuous row of feed, but this way we had a benchmark as to where we were starting from. The other thing, so we went ahead and fed either on the snow or into the bunk feeders. The bunk feeders themselves, we made them ourselves. They were 16 feet long, 4 feet wide, and about 30 inches high, so that we could actually get the processing unit in. We found out very quickly that the bunks filled up fairly fast, and we'll talk about a commercial type or an industrial type feeder that could be used in commercial operations. So the processor came along, delivered the feed, and we either went ahead and unrolled the hay for the second half of the first experiment using a unroller on the back of a 1-ton truck. And again, when we had the tarps out there, we'd cut a slice out of that windrow or out of that layer of bale that was delivered, weighed it out to get these to establish the weight of the feed that was being delivered on a linear foot basis. By week 4, we got into a situation where one of the areas was very heavy in snow, and we had to blade it back to get in there so that the bale unroller didn't get stuck. We did the same for the bale processor, and what we found was there was really no difference in how the cattle reacted to the feed. And when the results came through, they found that there was no real difference if you bladed off the snow or you fed them on loose snow. To excuse me, to make sure that we had control on what was being fed, we weighed every bale and made sure we delivered the right amount of feed every day. And we only fed at 90% of what is recommended for the animals. So they were always a little bit hungry, and that way it maximized the feed intake that they would consume on a daily basis. And therefore, we knew that we weren't overfeeding and contributing to the amount of waste that we were getting on the project. There are the cows feeding, heifers being fed into the bunks. In this situation, we had large tarps underneath the bunks themselves so that anything that was wasted around the feeder, when they pulled it out, it was also collected and measured as well. To get enough feed into those feeders, the operator of the equipment had to come back mid-afternoon and refill the bunks, but we made sure that they were getting the right amount of feed every day. Once the cows had grazed on the area and the feed was consumed, we tried lifting the tarps from the ground, and that thaw that we had a couple weeks earlier presented a real problem with trying to pull up the tarps and actually get everything collected to see how much feed waste there was. When we were digging through the areas that were used for feeding, we did find that whenever you looked at the snow profile, there was feed from the top to the bottom. The hooves are an excellent instrument to mix the feed through the layers of snow, and it really didn't matter if it was hard packed snow or loose snow. There was always feed going all the way down to the bottom. So when we pulled up the tarps, we'd get roughly 1,000 pounds of snow, manure, and feed on a 7.5 by 15 foot tarp. In that entire mass of snow, when we dried everything out, we'd get roughly 7 pounds of feed. So it took a lot of work and a lot of effort to get things collected and melted out and separated the feed from the manure. But when you do experiments like this, you've got to put the time in. The samples that we collected at the time of feed delivery and also from the wasted material, we ran it across a sieve with a 3/4 inch hole on 3-inch centers, so that basically we had the long material stay on the top of the sieve, and we collected that separately, and then the fine materials went down in the bottom buckets. So what we found was when we submitted the samples, we sampled the bales that we were going to use before the trial started, and that's what we'd consider to be an average value, or what we were actually putting out in front of the cows. and then when we put it through a bale processor, we collected the material, sieved it to see what the percentage of coarse material and percentage of fines is. And to substantiate the comment about the difference in quality, you can see the fine material, the leaves, the fine leaves, the flowers. You can see that your energy levels were up significantly. The protein content was a third higher in the fine material versus the stalks and the stems. Calcium, phosphorus, magnesium, again, you're going to see a lot of differences in them as well. So that's where we got for a baseline saying, okay, we've fed this amount of feed. We know what the original value is for protein off the average analysis. We know what we've got for the breakdown between the coarse and fine material. So the next step was when we did finish the sieving and getting into evaluating the feeds, we could work backwards and say, okay, we've lost this amount of feed. What was the quality indicator within that portion of the feed, using it being coarse or fines when we sieved it back? And then mathematically, we could see what the cows were actually eating and consuming for quality and volumes compared to just using an average value of so many percent loss. So with the meadow brome alfalfa hay, when we used the bale unroller, we got 12.3% physical waste. The bale processor, 19.2, and as long as the feed went into the bunk and the operator of the processor hit the bunk instead of the ground, there was virtually no waste on that at all. So what does that do? When you look at the percentage of losses, we know that the percent, for example, the unrolled hay with 12.3% physical loss. What was the nutrient loss in that? We found that the crude protein, we lost 21.5% of the protein, 25% of the calcium, 18% of the phosphorus, 21% of the magnesium. So in an alfalfa grass hay, where you do have higher levels of calcium and phosphorus, or higher levels of calcium, your problems with winter tetany or downer cows or milk fevers tend to be less of a concern compared to when you're feeding an straight green feed hay, which is shorter in calcium and shorter in magnesium compared to hays typically. So in this situation, we still had reasonable amounts of calcium and phosphorus, or calcium, phosphorus, magnesium, and potassium in the ration, so that it worked well. But if you were to do this experiment using green feed, and they had problems with this in Saskatchewan about 10 years ago, where they did feed a lot of green feed, they had a large number of downer cows. And I think the contribution of the loss, the actual nutrient losses, contributed to the problems with the downer animals that they had. So with the processed hay, using the bale processor, you're still losing the same amount of protein, but your calcium losses are higher. And the reason for that is you're shattering the leaf material away from the stem, and therefore the cows have a more difficult time picking anything up that's less than 3/4 of an inch in size out of the snow, sorting it out and picking it up. So I apologize for that. So if we looked at it on what the nutrients the cows actually consumed versus what was in the feed when we delivered it, the protein levels went down from 11% down to 8.4. Your fiber levels went down. Your calcium, again, from 0.48 to 0.32. You can see that with the delivered fraction of feeds, you almost have you've got a fairly decent calcium phosphorus ratio. It's almost it's 2 to 1. And yet when you look at your calcium phosphorus ratio for what they actually eat, you're getting down to about that 1.6, 1.7 range, which is at the point where you start getting concerned when you're running short of calcium. The processed hay, Same thing, you can see that your values went down considerably. So supplementation was more of a factor in this type of a situation, especially for adding extra calcium and extra magnesium to the ration, even though it was 20% alfalfa in that mixed hay. The gross feed wastage, you can see that 75% of the feed loss out of the material that was unrolled came from is the fine material, and about 18% of the total weight of the long material was lost, or roughly 1.6 pounds. So with the bale processor, same thing. The amount of fines was a lot more significant than the coarse material, which just confirms the fact that cows can't pick everything out of the snow, and they do have problems with losses in this situation. So if we look at the economics on this one, we're using 6 cents a pound for hay, which is fairly typical for this year. $175,000 for a tractor, $42,000 for a bale processor, and we went with a 1-ton truck with a Jiffy on the back for about $95,000. Your operating cost for the tractor alone is $85 an hour going to and from the field, and when you put the processor into there, you're at $106 an hour for the time that the processor is being used, and the truck basically kept it standard at $75 an hour. So with the total, with looking at the feed waste in for unrolling long hay or processing hay, what we found was the equipment itself, with the higher cost of using the tractor and the bale processor, the initial cost of equipment with feed was $1.98 for the unroller, roughly 25 cents cheaper than the feed delivered by tractor and bale processor. And when we looked at how much extra feed we needed to provide back to those animals to match the requirements that were initially set out in the ration, we needed to put another 38 cents worth of feed out to them with the unroller and 34 cents for the processor. And the reason for this is your protein loss with the bale unrolled baler, or the hay that was unrolled, had a higher percentage of protein loss than the processor, which seems strange, but that's the way the numbers turned out. So we actually had to provide a little bit more feed to match what was needed by the cow in the unrolling situation. Equipment costs, working it backwards for the extra time and effort that's needed to bring out the extra amount of feed, about 12 cents a day for the tractor and the bale processor, 8 cents for the truck. So your total cost per head per day ranged from $2.23 with the bales processed into the feed bunk with zero waste. We didn't have to supply an extra amount of feed or an extra time with the tractor, but you can see that the prices amounts went up by 20 to 40 cents or 45 cents with the equipment costs. So what does that do for on a per head per day or per head basis for 175 days feeding for what was considered a typical feeding period through agri-profits? You can see that there was $37 more expense when you fed the unrolled hay and $80 a head difference when you're using the bale processor. Any questions so far, Caitlin?
Not at the moment, Barry. Just a reminder to those of you on the line, if you do have a question for Barry, just type it in the question box and address it to me and I will ask Barry. But at the moment, Barry, no questions, so I'll turn it back to you.
Okay, thank you. So we started getting questions, okay, what can we use for a portable bunk feeder? And one of the gentlemen I was working with was pretty good with a welding torch and an arc and a MIG. So he just used drill stem, made the feeder 28 feet long. The walls were roughly 30 inches high so that the arm of the bale processor could go over the top, and made it 5 feet wide. So this model was made with vertical walls, And what we found was cows tended to jump into the feeder and create problems. So if you make it more of a soup bowl where the bottom of the wall was narrower than the top, so that there was a slant, when you've got a cow putting her brisket up against that bar, she tries to put one foot in. If she can't set that first foot down on the ground, she's got no option but to bring it back out, and she has to stay outside. So that's why we went with the slope, and we got that from Temple Grandin for a thought process and how to build this so the cows can't get in. Now, a feeder of that size is able to store a 1,400-pound bale of hay. It will fit in there processed, and that should be enough to feed about 40 cows. So there's an option if you want to build your own feeder. There's an idea of where to get started. The only thing I would do differently on a situation like this, you can see on the front end where the bars and the angle iron are set. There's no way to really get at that feeder. What I would do is I'd extend that, shorten the feeder by about a foot, and have the stub stepping the bottom rail out beyond the end of the feeder and have a little bit of curve at it. So if you needed to knock it with the front end loader to break it free, it's a lot easier to get at it. And the other thing is, if you have 3 or 4 or 5 of these to feed a couple hundred cows, set a couple grab hooks to get on the ends, hook them up with chains, and that way you can pull them along like just a bunch of rail cars on grain cars on the railroad. So we've got a gentleman that estimated the cost for us here about a month ago to build a feeder or something like that, and he said labor and materials would be roughly $1,100 right now. So if you've got a feeder that can handle 40 animals, and the value of the lost feed is worth $80 per cow over a 175-day feeding program, it would take about 60 days per the feed to pay for the feeder. And if it's built out of drill stem and built heavy enough, it should last you someplace between 15 and 20 years. So the second experiment was we wanted to deliver pit silage and round bale silage using the same protocols, feeding at 1.8% of dry matter of total dry matter intake. That's what's expected of the animal. So we did this work in 2009. The only thing that I had a little bit of fun with is I was actually at university when this experiment was being done and wasn't there supervising, and the operator of the silage truck misread the information and delivered 40% less feed than what he actually was supposed to. So the chopped pit silage on snow with the underfeeding of the chopped silage, we got 26.8%. If we would have fed the right amount, my guess, and that's all it is a guess, I would expect that to be someplace between 35 and 40%. Round bale silage on snow, 23.2. Now, for those that are looking at bale grazing, work done at the Lakeland Applied Research Association up in Bonnyville, they basically did the same thing we did here, but using round bales, and they found a 20% waste factor for that as well. So looking at the moisture content, or looking at the nutritional program with the high moisture round bale silage, again, we were losing 24% of the protein. You know, all those numbers are in that 20% range. So it's a little bit better than the alfalfa grass hay, where our physical losses were a lot higher, or our nutrient losses were a lot higher than the physical losses. These tended to be a lot closer to the physical waste to be equal to the nutrient losses from the feed. With chopped fit silage, same thing. We're looking about the same amount of losses both ways, physical wise and nutrient wise. The one thing we did see when they did put the round bale silage through the processor, we were finding barley kernels up to 10 feet or 30 feet away from the windrow. There was no way that we could tell how much weight that accounted for out of the feed. The only thing we knew was that a lot of the starch, a lot of the energy in that grain was not being consumed by the cow. But it was interesting, within the windrow itself, when we measured the amount of straw, chaff, grain, and leaves on the material that was sent, that was from the bales as they were being delivered, the cows did a really good job of finding the grain and cleaning it up within the windrow. When it was scattered like this, there was not much we could do. Cost of feeding silages. Using the bale silage and pit silage, all I did was converted the cost between the two so that it was equivalent on a dry matter basis. So it was roughly $2.47 a day for the feed. That's at $50 a ton for the silage and about $75 a ton for the bale silage. Equipment costs, I use the same numbers for the bale processor and tractor for this trial as was in the other one. With the truck delivery and the time that it took to load the silage into the truck, we figured that to be 75 cents a day. The big difference is with the feed containing that amount of water and the amount of waste, 24% waste, it was about 70 cents a day cost to increase the amount of feed being delivered. Equipment, 17 and 20 cents. So your total cost per head per day, it ranged from $3.24 a day up to just over $4. So from top to bottom, $567 for the cheapest way to do the feeding, all the way up to $700. So there was $150 difference. That's a calculation there. A little bit of a calculation area for the bale silage and snow, that 707. No. Anyway, there's something there that doesn't look right. But you can see that putting the pit silage or bale silage on the snow, you're looking at almost $150 a winter or $2 a day for an increased feeding cost when you have to supply additional feed and equipment time. So in conclusion, we want to use portable feed bunks or some sort of system to prevent the cows from walking over the feed as it's being delivered. That way you minimize losses. As forage prices increase, the repayment time or the repayment interval for the feeders to get them paid off decreases dramatically. And once you get into a higher quality feed, something that's got a legume in it, the alfalfas, the clovers, the vetches, where the leaves will shatter off and be lost. Same with some immature grasses. You're going to lose more quality compared to a silage or a more mature annual grain crop that's put in the round bale silage. So it's just to give you a snapshot of what we did. It's a situation where, yes, we've got our numbers, but that's one case, one scenario. What you need to do is take a look at your own operation. What are your costs for the equipment and feeds, and calculate out the potential losses that you're experiencing. So use this information as a guideline only, and get some help from an economist or somebody that's good with numbers if you need the extra help to figure out what's going on. Just about done. There's a new style of bale processor out where they've attached a hammer mill on the front of the wagon. So instead of just having flails catching the material and putting it out, there's a second processing system on the bale. Yeah, it's not the traditional hammer mill that you see on an old New Holland grain wagon or a mixer mill, But there's a second set of flails that's actually processing that hay again before it's delivered out to the animals. So the only thing I'm concerned about, and I don't have any hard numbers or data to support, but my thoughts on this one are, with the first experiment that we did, we found that the finer the material, the more material is going to be lost. So if you're running the hay through a second processing system and making that material more uniform and a lot more smaller material, is that going to reduce the amount of feed that the animals are going to be able to consume, and what's that going to do to the nutrient content? We don't have the answers for that. That's just questions that that I have in the back of my mind. Now, Karen Boschman, a researcher at the Ag Canada Research Station, did some work a number of years ago with straw and low quality feeds such as a slew hay and straw, and found that there was an increase in digestibility for the material that was less than 3/4 of an inch in diameter, or 3/4 of an inch in length. But the thing is, they were feeding directly into a feeder or a continual bunk feeder in the feedlot, and that's how they were able to determine what was happening. So I've just got a little bit of reservation in my mind. You're going to have to make up your own decisions as to, is it worth getting that extra secondary processing on these units or not? But we'll just leave it there and let you guys make your own decisions on what you want to do. Anyway, Caitlin, I am done. Any questions?
Not at the moment. If those of you on the line, if you want to ask a question, please type it into the question box and address it to me as the organizer, and I will pose those to Barry. Just a question, Barry, when you were doing all of these calculations, did those numbers surprise you when it came to all of those losses?
Yes, it did. I was expecting 20, 30, maybe $40 a winter with numbers back then. But when you start looking at the cost of the equipment, the diesel fuel, your time, the cost of putting up the extra feed, it really accumulates fast. And the other thing that came out by Dr. Harlan Hughes out of North Dakota State University, he was an extension economist, and he found that when you can reduce your winter feeding cost by $1, the overall net impact on your farm was an improvement by $2.48. So there's a big multiplier effect there. So, it's not just the dollars of feed that you're spending on. If you don't have the waste, or if you don't have to seed an extra number of acres of land to supply you the amount of feed, and you can plant it to a cash crop, that's going to affect your bottom line. And that's part of the logic that he was using in that situation.
And of course, this also shows that you really need to know your own cost of production in order to know the best way to make things work for you.
Absolutely. It's not always a portable bunk feeder. Some guys have used a fence line feeder that you can buy. It's a steel panel that's probably 16 feet long. And what they did was they set that panel out in the field and fed on one side of the panel and had the cows locked off with an electric wire so they couldn't come around the other side. And then they'd move that panel every so often, and that seems to be working very well as an option instead of buying a feeder or building a feeder.
All right. I don't see any other questions at the moment, so I'd like to thank people who are attendees today. And as mentioned earlier, the webinar was recorded today. You'll get a link to that in an email. Please feel free to share that with others. And also, I'd like to thank you, Barry, for your presentation today. Very informative. Just seeing those numbers, I think, is a real eye-opener. So I'd like to thank everybody. One other note, that after the webinar concludes, a survey will appear on your screen, and we would appreciate you taking the time to fill out that survey. We always appreciate the feedback. And again, you'll receive an email within the next day or two with a link to the recording of today's webinar. So thank you everybody for today's webinar.